All right, hello students. Today we're going to go over two different things. First, we're going to talk about the distributive property. This is very important when we get to as you're moving on in the 7th and 8th grades. So this is a very important property. And next, we're also going to talk about combining like terms. Chapter 3 starts kind of the very basics of algebra. Combining like terms is just taking our terms that we've known that we talked about before and combining the ones that are alike. We'll talk about that when we get to it. So first, we're going to talk about the distributive property. So here's our first definition. The distributive property is when you multiply each of the numbers inside the parentheses with the number outside the parentheses. So if you take a look here, it's going to highlight some key points. So the distributive property is we're going to multiply the numbers inside the parentheses with the number outside the parentheses. So let's go ahead and take a look. We'll go over an example. Let's look at example 1. So we look at this. 3 is outside the parentheses, and 7 plus 2 is inside the parentheses. Well, if you remember from last section, we look here. Remember what's going on right here when the number is sitting right next to the parentheses. Remember, what operation is that? If you remember, that's called multiplication. This is why we multiply this outside number by both inside numbers. Second, if we think of order of operation tells us we have to do what's inside the parentheses first. So 7 is 9, right? The answer is 9 multiplied by the 3. 9 times 3. We know our answer should be 27 when this is all over. Okay, so that's using our previous knowledge of order of operation. 7 plus 2 is 9. 9 times 3 is 27. Well, what the distributive property says or tells us is that we can take this outside number and multiply it by both the 7 and multiply 3 times the 2, and that should give us the same answer. That should still give us 27. So let's take a look and see how this works. I'll give it a try. Times 7, I get 21. You're going to bring down the sign that's in the middle. Today we're talking about just addition. And then we have 3 times 2 is 6. Well, now if we add these together, 21 plus 6 is 27. And as you can see, it matches. These are the same answers. Well, you might ask, well, Mr. Montgomery, why would I do that? Why wouldn't I just add these two together and then multiply by 3 and get 27? Well, you can do that for this type of problem, but when you get to an algebra problem, if we look at like a problem number 2 here, we can't do that anymore because of the x, because of the variable. So if they're just two numbers on the inside, of course you can add them together and get 9, multiply it by your property gets you the same answer. It still works. So let's look at it when we being multiplied by the two inside terms, 3x plus 5. So let's go ahead and distribute it out. So the 3 gets multiplied by the number 3, and 3 gets multiplied by the number 5. So 2 times 3 is 6. The x comes down next to it. We just simply leave it alone. The addition sign comes down. Then 2 times 5 is 10. So now, we can't combine these two together. We'll talk about this kind of in the next part because these are not like terms. So we can't add these two numbers together. This is our final expression. So and we'll kind of talk about that, why these are not like terms in the next video. So this is why the distributive property the 2 still to both of the inside numbers. So let's go over one more example. We have 7 on the outside. 7 is being multiplied by a plus 2. So just like before, we're going to distribute. The 7 gets multiplied by the coefficient in front of a, and 7 gets multiplied by the 2. Where everybody says, well, Mr. Montgomery, there's not a number in front of a. Remember, we talked about this quite a bit. There is always a number in front of a variable. If there's not a number in front of it, if it's 0, well, then the variable wouldn't exist. The variable wouldn't be there because 0 times anything is 0. It goes away. So remember, this coefficient is a 1. There's a 1 sitting here. So this is 7 times 1. And 7 times 1 is 7. You bring down the a right next to it. Bring down the plus sign. Bring the plus sign straight down. And then we have 7 times 2 is 14. This is using the distributive property. I can't add 7a plus 14 because they're not like terms. So that is your final answer. All right, so go ahead and take a moment, go and do a couple of examples on your own. Give the distributive property a try, multiplying the outside number by both of the inside numbers. Go and pause the video, give it a try, come back, and I'll give you the answers. All right, welcome back, students. Let's go ahead and go over the answers. Well, remember, distribute. 2 times 3 is 6. So 6x, the variable stays the same. 2 times 1, ooh, that's a bad arrow. That's okay. 2 times 1 is 2. And then bring down the plus sign. The sign in the symbol, the sign in the middle stays the same. So for this one, you should have got 6a plus 2. For the next one, remember this is 4 times, remember there's a 1 sitting here. So 4 times 1 is 4a. Bring down the plus side. 4 times 3 is 12. All right, so those are your 2 answers. If you didn't get one of these answers, please raise your hand so I can come by and see what you did. The distributed property is a very important property, not just for this year, but for years to come. All right, so go ahead and move on to the second video, and we talk about combining like terms. All right, students, welcome back. Now we're going to finish up our 3.4 lesson on combining like terms. And the video is talking about what a like term is and combining or simplifying like terms. So a like terms have the same, so they have to have the same letter or 2 letters together and are written to the same power. So the variable has to have the same exponent. For the most part in 6th grade, we don't worry about exponents a whole lot. That's more in 7th and 8th grade, but this is the definition. This is what a like term is, and it will come up a little bit, but for the most part, we don't worry about the exponent. We kind of concentrate more on the variable, making sure that they have the same variable or variables. So once again, key parts of like terms are they have the same variable or variables, might have more than one, and they are written to the same power. The variables are written to the same exponent. So here's a couple of examples of like terms. We have 2x here because this has an x, and 3x because they both have the x. They both have the same letter here. The next one here, these are also like terms. AB and 3b. Once again, here's our example of multiple variables. They both have the same excuse me, they both have A and B. If one of them was missing a B or missing an A, then they wouldn't be a like term. They have to have the same, exactly the same letters to be in the term to be a like term. Or the last one is they cannot have a variable at all. These are called constants. This is what you've been working with since pretty much kindergarten. These constants are what we start with. These are just numbers that are sitting there all by themselves, and these are alike. We can combine these 2 together. So we're going to talk about combining like terms. So finding terms that are alike and then grouping them together, adding, subtracting these like terms together. Today we're going to concentrate basically on just the addition part. Tomorrow or the next section where we're going to work on the subtraction portion, adding the subtraction into it. So, what we're doing today. Today we're going to simplify the expression by combining the like terms. We're going to put together the terms that are alike. So if we look at this, okay, here's our expression. We have 2x plus 3x. So these are like terms from above. I use this because these are like terms. How can I combine these together? Well, remember, the 2 here tells us how many x's we have. I have 2 x's here. So we can draw an example. So here, this means I have 2 x's. I have 1x, I have 2x. Here, we're going to talk about this says we have 3 x's. The 3 tells us we have 3 x's here. So let's go ahead and draw 3 x's. Very similar to first grade when you started adding and subtracting. Remember, we talked about, people said you start off with 3 apples. I give you 2 more apples. How many apples do you have altogether? Well, same thing is true here. I have 2 x's. I added 3 more x's. How many x's do I have altogether? Well, we can count. There's 1, 2, 3, 4, 5 x's. So that's how many x's we have altogether. Very similar to first grade when they talked about combining apples or oranges or fruit, whatever. Well, every single times are these variables. So how did I get 5 from this? Well, we add together the coefficients. Together gives us the 5. And then the x comes down next to it. That's how we get our 5x. So you could draw them out like we did up here, or we could just use our basic knowledge of math and just add together the coefficients. This is exactly what you did like in 5th grade, or 1st grade, excuse me. We're just adding together things that are the same. So these were both like terms, so that's our final expression is 5 times x, or 5 x's. And now, so we can move on to our next problem. So on problem number 7, there are 2 terms here that are alike and 1 term that is not. If we look here, we read this is 4a plus 5. Well, remember, like terms have, so let's go and underline our. So I want to combine these together. Here I have 4a. Remember, here I have 1a. How many a's do I have all together? Well, 1 plus 4 is 5a. Well, so I took care of these like terms. Now what do I do with this thing that's not alike? This plus 5. Well, I just bring it straight down. Since these are not alike, this has a variable of a, and this does not, then we can't combine these together. This is your final answer. That's why up in the previous example, or the distributive property examples, we couldn't combine these 2 together because they don't have the same variable. They're not alike. So we can't combine those terms. So that's pretty much combining like terms, but now let's go ahead and use our previous knowledge of distributive property that we talked about in the last lesson, and let's add that to the expression. Well, here we have the distributive property. Remember, order of operations says we have to get rid of these parentheses. If I look inside, I can't combine 2y and 4 because these are not alike. The only like terms I have are the y and the y, but I have to get rid of the parentheses first. Now, combining like terms only has to do with addition and subtraction. Multiplication and division, you can just multiply and divide the numbers like normal. Combining like terms is when you combine, you either add things together or you subtract by taking them apart. So when we're using the distributive property here, actually let's get blue, it's okay to multiply 3 times 2 because this is a multiplication, and that's all right. And you can multiply 3 times 4. This is how we get rid of the parentheses because we can't add or combine the terms inside. So 3 times 2 is 6y, just like we did in the previous lesson. Plus, bring down the addition sign, 3 times 4 is 12. Now, once again, I didn't touch this over here, so like everything else, if you don't touch it, you just bring it straight down. All right, well, now we go ahead and we combine like terms. So let's go ahead and underline what is the same. We have 6x, excuse me, and 3y. Go ahead and add the coefficients together. 6 plus 3 is 9. Bring down the y. And then we didn't touch the plus 12, so let's go ahead and bring down the plus 12. And there's your answer. We can't combine 9y and 12, so there is your simplified expression. Okay, this is algebra. This is the very basics of algebra. We can't combine the 9y and the 12. All right, so that's your combine like terms. We want to combine them together, the a's, the x's, the y's, or we want to find ones that are just constants, that are just simply basic numbers. Or these basic numbers you've been working with since first grade, and so you should be able to combine those together. So let's go and do a couple on your own problems. Just go and pause the video, come on back, and I'll show you what the proper answer should be. All right, welcome back, students. Let's go ahead and go over the answers. Well, for number 9, you should have combined together this 2x and the 7x. Combine these together, we get 9x. We didn't touch the plus 3, so bring down the plus 3. And there's your simplified expression. On number 10, we should have used the distributive property here. 2 times 2, 2 times 3, and got 4y plus 6. And then this one, we don't have like terms with the same variable, but we do have like terms that are constants. So we add the 6 and the 4 together, and we get 10. We didn't touch the 4y, so let's bring it down. And of course, this is an addition sign. All right, so you should be ready to go ahead and do your assignment today. If you got one of these wrong, please raise your hand.